then after that, once I've done this step, the other step is ICl solid reacts with Cl2. So I have ICl solid reacting with Cl2, but in my case, I have two ICl solids reacting with two chlorines to form two ICl3. I mean, it's this path. So my enthalpy change would be double this, minus 88 times 2, because everything got doubled. So that creates my other path. Okay, so once I have this other path, the enthalpy change, trying to figure out the enthalpy change of this reaction becomes very easy. So just a quick recap, you were being asked to find the enthalpy change of formation of iodine trichloride, which is ICl3 solid. It should form from its elements, which are iodine and chlorine. The first reaction was that iodine reacts with one chlorine. So iodine reacts with one of the chlorines to form ICl solid, 2 ICl solid. Two of the chlorines did not take part in the reaction. Next step, 2 ICl solid would react with two chlorines to form 2 ICl3 solid, which is this step over here. Is this part clear? Yes or no? बाकियों को, is this clear to ठीक है. So the rest of the step is easy. The two paths should be equivalent. So path number one, which is this one, should be the same. The enthalpy change would be the same as path number two. So that means 2x should be equal to, take out your calculator and solve this. 2x should be equal to plus 14, which is over here, and minus, I mean, if you take this path, it's going to be minus 88 times 2. So tell me what the answer is. Try and solve this uh, and find out what x would be equal to. And what is the answer that you're getting? Do you get calculators, please? I'm going to try and do this over here. It's 14 minus, I think, 88 times 2. And I think I need to divide minus 164 by 2. And I'm getting minus 82, which is not even an answer. Hey, why am I getting minus 81? You just, what was the calculation that I did wrong? It is C, but why am I getting the wrong value? It's 14, and then it's minus 88 times 2. अच्छा ठीक है, पता नहीं, for some reason I was getting minus 164. ठीक है. So the answer is going to be C. Achha, so we've done plenty of questions on Hess cycle. Now we're going to talk about the shortcut, how to actually figure out the shortcut for a Hess cycle. Now the shortcut is that so this would be referred to as the Hess cycle formula. So give me 1 second, let me get there. So now we're going to talk about how to figure out the enthalpy change by using a simple formula. The simple formula, Hess cycle formula, but it's conditional. It's conditional. You can only apply it under certain circumstances. So I'm going to just pick one question. Let me get this over here. Go back to just 1 second. I'm going back. This thing. Okay. You can try taking snapshots in between, or I can at the end of the day you can ask me for the whole sheet. I said this one. We're going to try, and the formulas are there. But before jumping on to the formulas, we need to first understand how this is going to work. So there's this question given, and the question states that if you can see properly, the question state that ethanol is increasingly being used as a fuel for cars. The standard enthalpy change of formation of carbon dioxide is given. So I'm going to write down equations. What is the standard enthalpy change of formation of carbon dioxide? I mean, whose enthalpy change is this? So formation of carbon dioxide is carbon dioxide formed from its elements. And they should be in their standard state. So it's going to be solid and gas, and this would be gas as well, right? So this enthalpy change is minus 393 kilojoules per mole. The next one is the standard enthalpy change of formation of water. So we have that value as well. It's minus 286. So standard enthalpy change of formation of water. Uh, so formation of water, that's going to be H2 gas plus O2, which is also gas, standard state. Elements forming water. Water is going to be in liquid state. And this has to be half because 1 mole of water should be produced. The enthalpy change for that is given as minus 286. So this value is also known. And then you have the standard enthalpy change of formation of ethanol. So standard enthalpy change of formation of, which means 1 mole of ethanol should be formed, which is C2H5OH in liquid state, and it should be formed from its constituent elements, which are carbon, hydrogen, and oxygen. And this should be half, this should be 3, this should be 2. This value is given as minus 277. So the value is given to us as well. So you're given these three reactions, their enthalpy changes are provided. What you need to figure out is the standard enthalpy change of combustion of ethanol. So we need to find the enthalpy change of combustion of ethanol. So what reaction is he talking about where ethanol is burning? It's going to be C2H5OH. It's going to burn with oxygen, combustion of ethanol, and it's going to produce carbon dioxide and it's going to produce water molecules. And since it's ethanol, there would be 3 water molecules and there would be 2 carbon dioxide molecules, and there are going to be 3 oxygen molecules. This is liquid, this is gas as well, and this is liquid. So we are trying to find out the enthalpy change of this thing. Okay, so I need to find out the enthalpy change. This is what he's asking for, the enthalpy change of combustion of ethanol. So I need to create this other path. Okay, I'm taking the longer route first, and then we're going to come to the formula. So I need to create this other path. If I'm able to create this other path, I would be able to figure out the enthalpy change of this particular reaction. To do that, I would have to first, I mean, there are three equations given above. So if you look over here, what you're going to notice is that there is carbon and hydrogen, and they're forming ethanol. So you have carbon, and you have hydrogen, and you have oxygen, right? And they are combining. I mean, these are my reactants, right? So carbon, hydrogen, and oxygen are forming ethanol, right? So it's this reaction over here, the one that we are looking at, the third one, that carbon, hydrogen, and oxygen, they react to produce ethanol. So carbon, how many carbons? 2 carbons, and they should be in solid state. And hydrogens, how many hydrogens? You need 3 hydrogens, and they should be in gaseous state. And you need half oxygens over here. Okay, carbon, hydrogen, and oxygen. So this should be half. So these three, they combine, and oxygen should be in gaseous state as well. So they're going to combine to form ethanol. But you have 3 oxygens over here as well. I mean, they're not doing anything in this reaction, so I need to add those 3 oxygens. Okay, they're not doing anything in this reaction. So I've written down oxygens as it is. So carbon, hydrogen, and oxygen are reacting to produce ethanol, and the value is minus 277. So this enthalpy change is minus 277. Then the other part is that carbon combines with oxygen to produce carbon dioxide. So I have carbon over here, and it can turn into carbon dioxide. I have hydrogen over here. It can combine with the oxygen to produce water as well. So this is my other path. Now this path is equal to minus 393, but it would be multiplied by 2. Acha, why 2? Because minus 393 was for forming 1 mole of carbon dioxide, where carbon and oxygen combine to form 1 carbon dioxide. Over here, I have 2 carbons, they're combining with oxygen to produce carbon dioxides, but you're getting 2 of them. So it's going to be minus 393 into 2. And in the same step, I'm also doing 3 hydrogens. I'm converting them into 3 water molecules. So I have 3 hydrogens, converting them into 3 water molecules. So that's going to be minus 286 times 2. So my Hess cycle is now complete. I mean, my products have been formed. So I'm going to just do a quick recap. This is the enthalpy change that I had to figure out: the combustion of ethanol, burning to produce carbon dioxide and water. So this is the value that I want to figure out. And I was given these 3 reactions, which are underlined over here. So I knew the enthalpy changes of these 3 reactions. So what I did was that there was a reaction given where ethanol was being formed from its elements. So I wrote down the elements and I tried forming ethanol. So the value was minus 277, which is given over here. Then I knew that carbon and oxygen can combine to form carbon dioxide, and I knew the enthalpy change, and hydrogen and oxygen they could combine to form water, and I knew the enthalpy change. So in this step over here, this is exactly what's happening. There are 2 carbons changing into carbon dioxides. There's hydrogens that are changing into water. So it is these 2 steps, a combination of these 2 steps. So it's minus 393 into 2 because you have 2 carbon dioxides that are getting formed. And this other one is minus 286 times 2, not 2. I mean, there are 3 water molecules. So it should be 3. Achha, so is this Hess cycle clear so far? Yes or no? Is this clear? ठीक है रिजा is अच्छा ठीक है so once the Hess cycle is complete, we can now easily do the rest, which is that one path, the enthalpy change of one path should be equal to the enthalpy change. Let's call this x. So the enthalpy change of this path should be equal to the enthalpy change of this other path. So I'm going to do my calculations now. So that means path number 1, which is x, should be equal to, the sign of this thing should change because I need to go from this point to this point. So I need to go in the opposite direction. So this would be plus 277. And the other ones would remain the same because I'm going in the same direction as the arrow. So it's going to be minus 393 times 2 and minus 286 times 3. And we can find the value of x. Now x would come out to be, if we use our calculators, it's going to, where's my calculator? So somebody, I think it's coming out to be minus 1367 kilojoules per mole. So minus 1367, and that's your answer. That's given over here. It's given as P. Achha, but this took a very long time to solve this. Uh, in creating the Hess cycle, it I mean you had to do a lot of things. You had to do a lot of working, and it's only a 1 mark question. So you just wasted a significant amount of time trying to solve a 1 mark question. Achha, anyways, uh, now the thing is, that under certain conditions, there are a few formulas that can actually simply work. And the formulas are that, and I'm going to do the formula right next to it, on top of it. So what was the enthalpy change that we were trying to figure out? The enthalpy change that we had to figure out in this question. So I'm going to use the formula now. They had asked us to find out the enthalpy change of the combustion of ethanol molecule C2H5OH reacting with oxygen to produce. We had to produce carbon dioxide and water molecules. Liquid state, gaseous state, oxygen is in gaseous state, and you have liquid state, and this would be 3 and 2 and 3. So this is the entire reaction we had to figure out, the unknown. Now, I'm going to solve the whole question using formulas now. Now, the reaction that you're trying to figure out, it's irrelevant, whatever it is. We don't care whether it's combustion or formation, whatever the reaction is. The reaction itself is irrelevant. I mean, we just need to figure out the enthalpy change. So it doesn't matter whatever the reaction is. We just simply don't care. So remember one thing: the formula doesn't really care about. I mean, you can apply the formula to any reaction whatsoever. But the formula says that if you know the enthalpies of formation of all the reactants and all the products, okay, so if you know the enthalpy of formation, so the formula simply is that if you know the enthalpies, if you want to figure out the enthalpy change of a particular reaction, and you know the enthalpies of formation of the reactants, and you know the enthalpy of formation of your products, then there's a simple formula for finding enthalpy change, this enthalpy change. That you sum up the enthalpies of formation of products and subtract the enthalpies of formation of reactants. But it's conditional. I mean, the condition is that you must know the enthalpies of formation of all the reactants and all the products. But you must know every enthalpy of formation of every substance in the equation. Only then would you be able to apply the formula. So I'm going to apply the formula now. If I start applying the formula, my products are carbon dioxide. So they've given me the enthalpy of formation of carbon dioxide. If you look at the question, they've given us the enthalpy change of formation of carbon dioxide, which is minus 393. So I know that. So I'm going to put them in brackets. These are my products, minus 393. But since there are two carbon dioxide, so I'm going to multiply it by 2. What is my other product? The other product is water. The enthalpy of formation of water is also provided over here. If you look over here, it's given as minus 286. So that is also provided. So it's going to be minus 286 times 3 because 3 water molecules. So these are my products. And I'm going to subtract these are my products, and I'm going to subtract my reactant, the enthalpy of formation of my reactants. So what are my reactants? There's one reactant which is ethanol. So I need to have the enthalpy of formation of ethanol. Okay, Sanjida, now I'm going to repeat. When would this formula be applied? I told you that the reaction itself is completely irrelevant. Whatever the reaction is, we don't care. Okay, so the formula is not really dependent on. I mean, you can calculate enthalpy changes for any reaction whatsoever. But the condition is that whatever the reaction is, you must know the enthalpies of formation of the reactants, both reactants and all your products, enthalpy of formation of your products as well. So Sanjita, is this clear? When are you going to apply this formula? So what people get confused with is they start looking at the reaction. Okay? So I'm saying that the reaction could be any reaction. Okay? Just don't care about the reaction, whatever the reaction is. What you need to care about is whether the enthalpies of formation of the reactants are given and whether the enthalpy of formation of the products are given. If they are given, you can find the enthalpy of this reaction without drawing a Hess cycle. So I said, what are my reactant? It's ethanol. So I need to find the enthalpy of formation of ethanol, which is also provided over here. It's given as enthalpy of formation of ethanol is given as minus 277. So let's put that out there, minus 277. There's only one ethanol, so I'm not going to multiply it with anything. And I also need to find the enthalpy of formation of my other reactant, which is oxygen. Now, when we were doing definitions, I had specifically told you that elements, they don't need to be formed. So the enthalpies of formation are zero. Okay, I told you specifically that about enthalpy change of formation that any element has an enthalpy change of formation which is zero because you don't have to form. The definition of enthalpy of formation was that you need to form 1 mole of element, 1 mole of a substance from its element. Now you can't form oxygen from oxygen. That pretty much means you're not doing anything. You don't have to do anything. So the enthalpy change of that part is zero. I said, can anyone do the calculation now? What is the value that you get? Hiba, Nida, can you do the calculation as well? Okay, it's again coming out to be minus 1367. So without actually doing any of this, without actually drawing any of the Hess cycle, we were able to actually calculate the answer exactly the same. You're getting the same value. So the formula is, and it's a very simple formula, whatever the reaction is, I mean, any equation, we don't care, whatever the equation is, as long as you know the enthalpies of formation of the reactants and the enthalpy of formation of the products, the value is going to be just sum up the enthalpies of formation of products and subtract from the enthalpy of formation of the reactants, and you're going to get your answer. Is this clear? Yes or no? Is this clear to everyone? Baki bhi Rida, Hiba, Usman. Rida, is this clear? Hiba, are you online? I just we're just going to stick. I said right now we're just going to stick with the. I said right now we're just going to stick with the first formula. Okay, so it's now all the questions in this worksheet you don't need to actually draw the Hess cycle. Okay, drawing the Hess cycle is very difficult. So I'm just going to do this question. So we need to figure out the enthalpy change of this reaction, right? What are we given? We're given the enthalpy of formation of H2S. So enthalpy of formation of H2S is given. You're given the enthalpy of formation of H2O liquid. So enthalpy of formation of H2O liquid is also provided. You're given the enthalpy of formation of SO2, so that's also given. And the enthalpy of formation of oxygen is already known at zero, right? So try and find the enthalpy change of this reaction. What you need to do is you need to apply the formula product minus reactants. So the enthalpy of this particular reaction, the one that's underlined over here, is going to be the enthalpy of formation of the product. So it's going to be products delta HF. So we're going to write the product first. So 2H2S, that's going to be product minus reactants, two water molecules. So it's going to be minus 286 into 2 because I have two water molecules and 2SO2. So that's minus 297 into 2. So these over here are my products and the enthalpies of formation. And subtract from the reactants. The reactants are 2H2S. So that's minus 21 times 2, and the other one is 0. So this is delta HF, delta HF. Can anyone calculate what is the answer that you're getting? quickly. Okay, so it means B is going to be your answer in this case. Okay. Next one is again the same. You want to figure out, and remember I told you that the reaction that you're trying to figure out, that's irrelevant. Okay, it doesn't really matter whatever the reaction is. So he's asking you to find the enthalpy change of combustion of methane. Methane would be CH4, burn it in excess oxygen to produce carbon dioxide and water. And you can balance this. This is going to be two oxygens, right? What are you provided with? I mean, you need to figure out the enthalpy change of this particular reaction. You're being provided with a few things. You're provided with the enthalpy of formation of carbon dioxide, so this is known. You're also provided with the enthalpy of formation of water, so this is also known. And you're also provided with the enthalpy of formation of methane, so this is also given. And the enthalpy of formation of oxygen is also by default known. So the enthalpy change of this reaction would be products minus the enthalpy of formation of reactants. So let's try and calculate the enthalpy of this reaction. It's going to be product is carbon dioxide, so that's minus 394. The other product is two water molecules, so that's minus 286 times 2. So this is the enthalpy of formation of my products. And subtract my reactants, which is CH4. O2 is 0. So enthalpy of formation of my reactant, which is, I think it's minus 74. So it's the product enthalpy of formation minus the. So what do we get in this case? Okay, so you're getting so minus 892. Okay, so you're getting minus 892. Let's look at this question exactly the same. You're being asked to find out the enthalpy. So these are very easy questions. You're being asked to find the enthalpy of this reaction. So you don't have to draw those complicated Hess cycle equations. So the reason in the previous worksheet we had to actually draw them was that these were not enthalpies of formation. So you had to actually create this other path, which is why these questions were very difficult because you had to, I mean, there was no other way. You can't apply the formula in this case. But in most of these questions, the formula is easily applicable. You have the enthalpy of formation. You have the enthalpy of formation of MnO2 as well. And you have the enthalpy of formation of NO2 as well. So you can easily solve this question as well. So it's going to be, the expression would be product minus reactants again. So it's going to be product is minus 520. The other product is 33 times 2. Add them up. These are my products. Minus my reactant, which is minus 696. Yes. To get that, and that's going to give me my answer. So the other thing that I wanted to discuss was there's another formula, which is that if in a particular reaction, I mean, this is the other formula. Uh, the other formula is that if you, I'm going to write it over here. So formula number 2. The formula number 2 is that there's a reaction going on. And again, we don't really care what the reaction is. Okay, so whatever the reaction is, that's completely irrelevant. So there's reactants changing into products. Now, what if you know the enthalpies of combustion of the reactants and you know the enthalpy change of combustion of the product? Then your formula is that the enthalpy change of this particular reaction is going to be the enthalpy of combustion of your reactants minus and the sum of them minus the enthalpies of combustion of the products. So this over here is going to be the formula of this for this question. So this is the second formula, and the second formula is reactant minus products. But for this formula, you need to know the enthalpies of combustion. So there are two formulas. One is that you either know the formation enthalpies of the reactants and the products, or you know the combustion enthalpies of the reactants and the products. Uh, so there are going to be two different formulas. One would be product minus reactants. For formation, it's product minus reactants. Okay, we can highlight this. And for combustion, it's reactant minus products. So I'm going to apply this formula. Okay, let's have, this one. So let's look at this question. Again, you don't have to draw the Hess cycle because in the entire question, you're being asked to find the enthalpy change of this reaction. And what you have is that you're given the enthalpy of combustion of carbon. You're also given the enthalpy of combustion of hydrogen. And at the same time, you're also given the enthalpy of combustion of C4H10. I mean, all three values are given. So you're going to apply, if you want to figure out the enthalpy of this particular reaction, the one that's in front of you, then the enthalpy of that particular reaction is going to be this reaction over here. It's going to be reactant minus products. You sum up the enthalpies of combustion of the reactants and subtract the enthalpy of combustion of the products. So enthalpy change of combustion of reactants minus so it's going to be minus 394 into 4. The other one is minus 286 into 5. These are my reactants. I mean, these two are my reactants. Minus products. My product is C4H10, which is, it's important to use brackets because you're going to get the signs wrong a lot of times. So you have to be careful with the signs. And so what's the answer to this question? Okay, so we have an answer. So these questions are very easy and it's very quick to solve the question if the formula is with you. Most of the time, the questions that you're going to get would be very similar to these questions over here. Sanjita, this formula would be used, like I told you, that to use this formula, again, don't look at the reaction. Okay? The reaction has nothing to do with your choice. The reaction could be anything. The formula would be used if there's a table given or this information is given, that you know the enthalpy of combustion of all the reactants, every single one of them, and you know the enthalpy of combustion of all the products. If that is known, if all these enthalpies of combustions are known, then you can use this formula. Okay, Sanjita, is this clear? The other formula was used. The other formula was used if enthalpy change of formation was given for all the reactants and products. So, for example, if you look at this next question, now you can clearly see that enthalpies of formation are given. You're given the enthalpy of formation of NH3, you're given the enthalpy of formation of NO, you're given the enthalpy of formation of H2O, and O2 is already known. So which formula would you use if you want to figure out the enthalpy change of this entire reaction? the formula that you're going to use is that the enthalpy of the reaction is going to be so the first one exactly. So it's going to be products. You sum up the enthalpies of formation of the products and subtract the enthalpies of formation of your reactants. So you can try this. It's basically you just have to apply the formula. There's nothing to it. Sometimes, I mean, for example, this question, actually they've given you this is enthalpy of formation of SO2, this is enthalpy of formation of SO3. So again, you have the enthalpy of formation of SO2 and you also have the enthalpy of formation of SO3 and you have the enthalpy of formation of O2 by default because it's 0. So again, it's going to be product minus reactants. Enthalpy of formation of products minus the enthalpy of formation of my reactants. Okay, so a lot of cases, these two formulas. Just have a quick look. Again, in this equation, enthalpy of formation of everything is given, the reactants. Mg is an element, so that's 0 because you don't need to form Mg. So it's going to be product minus reactants. And you were supposed to quote an expression. Now this one is, they're asking to find out the enthalpy change of this particular reaction. So it's the formation of propanone, which is given over here. C3860. Okay, remember this reaction that they're trying to find out, that's completely irrelevant. We don't really care what the reaction is. So it's going to be 3 carbons plus 3 hydrogens and half oxygens. So what is provided to you? In this question, you're provided the enthalpy of combustion of hydrogen, that's given. You provided the enthalpy of combustion of carbon, that's also given. And enthalpy of combustion of propanone is also given. Enthalpy of combustion of O2 would be 0 because you can't burn oxygen in excess oxygen. That's the product is going to be oxygen again. So if combustion are given, you're going to use reactants minus products. Okay, is this clear to everyone? Okay, Hiba, is this clear? So the only difficult part is I sent you a video lecture. This part is difficult and it's actually very difficult. Okay, drawing hair cycles, that's very difficult. Most of the time you don't even get questions like these, but drawing hair cycles can be confusing and they can be very time consuming as well. So this part is difficult. You don't get a lot of questions, but you do get some questions on them. Most of the questions would be as easy as the ones that we did over here. Simple. It's either product minus reactants or reactant minus products. That's your shortcut, and you can use that to answer any question. So I think we'll continue with this next class then. Okay. Any questions about this? Everything clear? So we can continue in the next class. Okay. So okay, take care then. Allah Hafiz.